Okay, well, we're going to have two of them today, and we'll have probably about 10 minutes at the end to kind of talk about what we've learned and some of the highlights and whatnot that we've seen. So let's learn about the Ice Age. Yes.
Well, we're in the Mount Baker ski area near Mount Baker with Mount Shuksan in the background over here with this beautiful glacier on the top of it.
It's absolutely gorgeous. You don't see glaciers very often. They're kind of a unique thing, aren't they?
Well, you have to get up in the high mountains today in order to be able to see them, and they're much smaller than they used to be. Glaciers used to be much larger than this.
How big? Are we talking about just twice that size? Or?
In the past, glaciers have covered these mountains down even 3,000 feet lower than we have today. But even before that, ice sheets, which are basically glaciers on flat terrain, covered major areas of the world. For example, in North America, the ice sheets extended clear across Canada. They extended down into the United States. So that period of time when that much ice was here, that was the Ice Age.
Well, I think most people probably think if you just lower the temperature, you can get an ice age.
Well, it doesn't work that way because you got to get the water vapor from somewhere in order to produce the snow. So somewhere you have to have warm temperatures and you have to have cold temperatures. And we believe that's what happened during the Ice Age, that in the past that the oceans were much warmer and the continents were much colder, so that when water vapor that was evaporated out of the ocean was drifted over the cold continents, it then fell out as snow and ice.
As an atmospheric scientist, what do you see in the past that would have caused those unique conditions?
From my perspective, the Bible really gives us a clue as to what happened that caused the Ice Age. The Genesis flood was a magnificent, catastrophic, high-energy event, and it left the oceans warm. And it took about 1,000 years for the ocean to cool back down to the temperature that we have today, where it's uniform. But during that period of time, particularly right after the Genesis flood, when the oceans were the warmest, it produced a tremendous amount of heat and evaporated water into the atmosphere, which then fell as the snow and the ice on the continents, forming the Ice Age. So the Genesis flood was actually the cause of the Ice Age.
Larry, that sounds like we have some very, very unique conditions then.
Yes, they were. For example, we know that there were a lot of activity in the ocean. The plates that we are aware of on the surface of the Earth today, between those plates there were cracks where magma came up, hot magma from the mantle, spewed out on the bottom of the oceans and formed a gigantic mountain chain. And that 40,000 mile long mountain chain of hot magma, as it cooled, warmed up the ocean. And we have that information from estimates of sea surface temperature from seafloor sediment data. And the conventional community believes that as well. It's just they have a different age for it, 65 to 100 million years ago during the Cretaceous period when it was that warm. And that would have produced a tremendous amount of evaporation, which then drifted over the cold continents. Now, the continents, we believe, were cold because of volcanic dust and material being lofted into the atmosphere, into the stratosphere, a high atmosphere, which blocked off the solar radiation coming in and warming the continents. And it kept it cold so that you had the warm oceans, the cold continents. Therefore, you had lots of water vapor evaporating and being converted into snow and ice to form the ice sheets and glaciers on the continents.
So all that warm water and the cold continents over a long period of time then produced those very, very huge ice sheets you were talking about.
In fact, some of the modeling work I've done using conventional models but with a very warm ocean produced precipitation rates that would have produced ice sheets and glaciers 5,000 to 6,000 feet thick in a matter of 500 years or less. And it may have taken another 300 or so years for them to melt back at the end of the Ice Age. Now, the intensity of this occurred around the time of Job. That's why when you look in the Bible, you don't find any reference to the Ice Age, but you hear Job, he says, out of whose womb came the ice. So in the area around Israel, for example, the most likely place that he would have seen snow would have been on Mount Hermon. Now there's ice and snow up there occasionally in the wintertime there, but it doesn't extend down very far and it doesn't last very long. But during the Ice Age, it may have been that Mount Hermon had a permanent glacier on it.
So this is the age of Abraham as well.
Well, just even in Israel, we think of it as strictly a desert like we see there today.
Sure.
But there's evidence that in the past it was a much more moist, wetter environment. In fact, I have found that the precipitation may have been as much as 3 or 4 times what it is today, back during the time of Job and Abraham, and that whole country may have been moist and green. You know, the Bible talks about the land of Israel being a land flowing with milk and honey. The Jordan River Valley was green all the way down to the Dead Sea. So it's just amazing what a warm ocean and cold continents will do in a very short period of time.
All of this brings up some interesting things, like the woolly mammoth that's frozen, maybe even has buttercups in its mouth. How does that fit into all of this?
Well, the conjecture is that many of them were up in the northern part of Siberia, which was south of the Arctic Ocean. It's likely that the Arctic Ocean was warm as all the other oceans were, and it would have taken maybe 500 years for the Arctic Ocean to finally freeze over. And at that point, then you begin to accumulate the snow and the ice. Right near the Arctic Ocean, it was maintained a relatively warm climate. So they would have been able to stay there and repopulate the Earth. But during that time, the snow and ice further south, which would have been colder, further inland from the Arctic, and kind of formed a barrier where they couldn't escape. And eventually, when the Arctic froze over, then the whole climate changed, and then they were frozen. Now, why they ended up with fresh buttercups in their mouth is quite a mystery. And that implies that near that warm climate of the Arctic Ocean, you could have had vegetation that could have grown. They could have eaten that, and then suddenly there would have been a really strong storm of some kind, or a series. The weather changed rather dramatically when the Arctic suddenly froze solid, and they were frozen.
So we're back again to another catastrophic event.
Well, the world was continuing to change rather dramatically, continually, as the Ice Age developed and then eventually came to its maximum and then began to melt back again. During that time, people were moving over the whole surface of the Earth. The ocean levels were changing, the climate was changing. Slowly, volcanoes and earthquakes and all those began to decrease in intensity. So there was a tremendous dynamic going on for 1,000 years or more after the Genesis flood.
Well, there is a lot of talk about climate change today. How does that fit into what you understand?
Well, some people are concerned that we may be going back into another ice age. And this really it helps us to understand why some people are so concerned about a short period of global warming or cooling. There's a viewpoint within the community of paleoclimatologists, these are people who study old climates, that just before an ice age starts, they believe that there's an instability, so that the climate gets very warm and then it gets very cold and it's oscillating. And so they see the climate as very unstable, very sensitive to small changes. So that if we put in pollution in the atmosphere, the particulates or gases, and possibly contribute to some instability, that it will suddenly go to an ice age. As a young Earth creationist, I believe that the atmosphere and climate is very stable. In fact, it took a major catastrophic event like the Genesis flood to kick off the climate change that we saw that produced the ice age. So that's why there's a major difference in viewpoint between different people about how unstable or stable the climate is. We would basically say there was only one ice age following the Genesis flood, not multiple ice ages or up to 60 different ice ages. These are derived primarily from seafloor sediment data. Ice cores don't show that many, but they interpret the wiggles in the temperature estimates from the seafloor sediment to get these many ice ages. But even those have major problems because the seafloor sediment that is looked at is on the order of 20, 30 meters or 60 to 100 feet of sediment. And you're trying to interpret multiple ice ages that occurred over millions of years from layers that are on the order of less than a millimeter thick. And it's almost impossible to interpret it that way. So there's a real challenge to justifying more than one ice age.
Looking at this from then the conventional paradigm, how do they come up with the means by which an ice age can occur? You were saying an ice age requires some very unique conditions.
Generally accepted conventional explanation for the ice ages is something called the Milankovitch or the astronomical theory. And it was developed back in the 1970s based upon a hypothesized correlation between the way in which the Earth orbited around the sun in an ellipse, and it goes into a circle and then back to an ellipse, or the Earth's orbit wobbling slightly, or the Earth's position in this ellipse going around the sun. It's hypothesized that this correlation results in about a 20,000 or a 40,000 or a 100,000 year period between ice ages. And that's been the generally accepted idea of what causes the ice ages. But there's several major problems with that model. One is that the 100,000 year period is the one that's generally accepted as the period of the ice ages, and that's the weakest correlation with the seafloor sediment data. So therefore they have to suggest some kind of a feedback mechanism or some way to make this weak signal amplified so it produces the ice age. So they suggested this idea, and they call that the pacemaker of the ice ages. Kind of like the heart pacemaker, you know, it's a slight electrical impulse to cause the heart to beat. So they're suggesting that the one orbit that's about a 100,000 year period has enough, just a little bit of an energy to cause that ice age to begin and then end in 100,000 years. But they don't know what that physical process is that amplifies that signal. So it's a very weak argument. There's not enough energy to explain how you get the cooling you needed to occur all year round. There's been a lot of modeling, for example, attempted on explaining the ice ages in a uniformitarian viewpoint, and there's not been any success in being able to explain an ice age with this uniformitarian viewpoint.
So again, the conventional paradigm seeks to understand all of that through current processes. We have almost natural events going on that create ice age after ice age, as opposed to what you're saying, and that is that if you're going to get an ice age, you have to have some really, really catastrophic events and some very unique conditions.
Very high energy events in order to be able to cause the atmosphere to react the way it did.
Yeah. Well, Larry, that brings us to an issue that a lot of people have, has to do with ice cores and the dating associated with those ice cores. What has your study shown?
Well, first of all, ice cores are made generally in Greenland and Antarctica. That's where they come from. It's a very large amount of ice there, and it's basically maintained itself the whole time. Cores are taken by drilling about a 6-inch to 8-inch core down through the ice, drilling down all the way down to bedrock at the bottom and pulling them out very gently, maintaining them in cold conditions so they're preserved. And then you look at the detail in the ice through that long length. The ones from Greenland are about 4,000 to 5,000 feet long. The ones in Antarctica up to 9,000 feet long. And in there you have visual layers that you can look at that were formed as the ice compacted and it went from snow to ice, and it maintained the bubbles that are in there. It has various chemicals that are in there, dust layers that are in there, looking at oxygen-18 isotope ratios. From all of those various features, you can see the variation with time down through the ice core as it accumulated material. For one thing is that you would expect there to be one ice age following the Genesis flood. And you see that in the record. Where most of the evidence is presented that there were multiple ice ages is at the very bottom of the core, where it's the hardest to interpret. And it shows that it was disturbed very strongly down at the bottom of the core, as well as the fact that there was all kinds of dust and chemicals and features that you have a very difficult time trying to interpret. If, in fact, the Genesis flood was caused by a catastrophic event, and it produced all kinds of volcanic eruptions and the Earth's surface being disturbed greatly, you would expect to see that at the bottom of the core, and that's exactly what you find. And it's not just a small, thin layer down there. It's up through quite a depth through at the bottom of the core. So that fits very naturally with the Genesis flood idea with the catastrophic process that occurred there. Now, there's also some question that's often brought up about the formation of ice in Greenland, for example, and how that accumulated. There was a recent incident that occurred at the end of the Second World War, which is quite fascinating. There was a squadron of P-38s and a couple of B-17s that were flying from North America over to England at the end of the war. And that was over 50 years ago now. And they got stranded out in the middle of the North Atlantic, so they ended up crash landing on the southern coast of Greenland. But they were rescued about a week later. But the planes were left behind. And there was a wealthy Texan who decided to go looking for these planes because they were very valuable to restore, particularly the P-38s. So they went looking for the planes on the southern coast of Greenland, and they couldn't find them for about a year because they had moved. The ice was slowly drifting toward the Atlantic and calving off and disappearing. But they looked about 10 miles from where they knew they had crash landed and found them 250 feet down in the ice. What had happened was the average precipitation that occurred on the southern coast of Greenland was an average of about 5 feet of ice per year, solid ice, that accumulated. So in 50 years, you got about 250 feet of ice above the airplane. So they were buried down there. Now, what's that got to do with the Ice Age? The importance of this was, how do you get that kind of accumulation of ice in Greenland in that short of time? The normal amount of ice that accumulates in Greenland is less than a foot a year, typically in Greenland. But on the southern coast of Greenland, where those planes happened to have landed, was where the Gulf Stream intersects with Greenland, which is a warm ocean current that comes up the east coast of North America and is a large source of water vapor off the coast of this cold continent, very much like what we've talked about globally. So this is a small scale event that would produce an increase, a 5-fold increase in the amount of precipitation in just that southern part of Greenland and accumulate that amount of ice.
And those are the unique conditions you were saying were required.
But it was globally. It was
Yes.
global instead of just this little local area. So it's very, very convincing.
A lot of people think that you can just count those layers in the ice core like we count tree rings. Is that true or not true?
In the upper part of the core, you can count the layers. But when you get down further, where they've thinned so greatly, and there's such an incredible difficulty in interpreting all the various information, you cannot count them as individual rings, particularly visually. And even the chemical compositions and the oxygen 18-16 ratios and so on, there's a tremendous controversy on that. So basically, you can estimate it for one ice age, but it doesn't go back to hundreds of thousands of years, and you cannot count them as annual layers. There's too much difficulty in interpreting the record.
So it seems we have some real differences in the assumptions associated with how we count those layers.
Well, if you had a considerable amount of precipitation following the Genesis flood, you would have had a lot more precipitation than is normally assumed. Down in the middle of the core, things get so thin that you can't really interpret it correctly. The amplitude from the oxygen 18-16 ratios are almost impossible to interpret in terms of annual layers. And in fact, these layers can be easily interpreted as storm layers, not annual layers. So that if you assume that, say you had a storm every 3 days, you would have 120 of those layers in 1 year, not just one layer. And so these interpretations are very inaccurate. And so you can't assume that in each individual layer is an annual layer. It's not hundreds of thousands of years. It could be just a few thousand years.
You love this work, don't you?
Oh, I've done it for years, yes. That's why I got into it. I love atmospheric science.
This is the kind of thing that I would hope that young people would begin to see, that this is a frontier for them.
Well, that's one of the reasons I got into it. When you work in conventional science, typically you don't get to ask the big questions. But as a creationist, I'm able to ask questions that nobody else is asking because I'm looking at what the Bible is saying and applying the Bible to my science and asking questions that are actually surprising when you find the answers that you get from your research. It's exciting to be able to do that sort of thing.
So, to me, just from this, I don't believe the Russians.
Oh, they're talking, they have.
Well, another ice age, they're saying.
Well, they were talking about like what happened back in the 12th, 13th century.
Oh,
Things just got colder. We're not talking about this. No, not at all.
so I mean, he had a lot of good information there about, some of the items that they can, I don't know, what you guys get out of that? There's a lot of,
But
Scientific stuff I didn't-
Your approach.
well, the thing is too, I mean, he's got the Bible to go on. He's asking questions that nobody else understands. Why, and it's being answered by the cores that they have there. If you're gonna, like he was talking about, those real thin layers all the way up through, that's just a storm.
Yeah.
And you can have several storms throughout the day, throughout the year. And that, it's not really counting it properly.
Seems like, seems like the evidence that they're looking at is very difficult to interpret. So it would make me think that the science at this point is suspect when it comes to accuracy.
Well, throughout the whole thing here, what I've seen is that the conventional paradigm that we've all learned and all that stuff, they try to fix the science to fit that paradigm. They're not looking for actually what happened. So, yes,
when he started out, like saying the upheaval and all the magma cooling, and we know that heating and cooling creates expansion and contraction. And I think about when we teach our students about the plate tectonic theory, and like you said, they have the whatever the science to
Mhm.
fix it. But if you look at what he has said, and if you had taught, the kids would learn from the basis of creation, then the truth would come out, because they're just learning a theory
Mhm.
that they memorize without any facts.
Mhm.
Because it just happened like that. But if they saw exactly what happened, the upheaval, the catastrophic upheaval of what happened, and then the separation of the continents, then they will get a better understanding
Mhm.
of how it actually started.
Yeah, because throughout, all of these PhDs that are on that have been talking so far, I mean, they're coming from that, and they're showing why it's a better fit
Right.
with what the Bible actually says, because that's what they're seeing in everything that they've been doing their research on, and why there's still so many more answers that need to come, and that's why there's trying to get younger folks into it to be able to see that and stuff. So I mean, it's quite a battle between the two. Um, I don't know.
It's
one of those things. The world is not going to allow it. You're exactly right. And so they'll know it at a place and time, but it'll be too late at that point. So that's why I think going back to the beginning of, and even Steve Austin here says it. He says this changed his philosophy all over from what happened and, with the Mount St. Helens, because they learned a lot of how quickly things can happen in just a matter of minutes, sometimes seconds, with what's going on here. So that's kind of why I wanted to go back to the beginning because maybe some of you guys weren't here to see it, but now, after you've gone through all this, maybe it'll make more sense as to what actually happened there. If not, it'll just be a reminder for you, so. And we'll have some time after this to talk as well.
Is that a waterfall up there?
Yeah, big one. And that's a couple 100 feet high. And whole canyon 600 feet deep.
Have you been up there?
Yeah, that's a cool place.
Huh.
Yeah, you can see everything around the volcano there.
Yeah, and all this just scoured. Steve, it's absolutely beautiful here. That's just the peaceful, quiet, and almost overwhelming beauty. And yet, it wasn't always that way.
On May 18, 1980, a catastrophic geologic event occurred that not only shocked the world with explosive power, but it challenged the way we're thinking about the origin of the Earth at its very foundation. That event is the eruption of this mountain here in Washington State 35 years ago.
So Steve, tell us about that. What happened on that day?
The eruption on May 18th was really a 9-hour event. And if you think about the 9-hour event, there were 7 different sub-events that were going on during that big event on May 18th. 17 seconds after 8:32 in the morning, there was a big earthquake, magnitude 5.1. It shook the north slope of the mountain. The oversteepened and cracked north slope began to slide, and it formed this gigantic rock fall that became mixed with atmosphere and gas and dispersed, and it became a debris avalanche. And this debris avalanche overtopped this ridge and went 10 miles from the volcano. And then behind that avalanche, the pressure inside the volcano was released, and super hot liquid water in the neck of the volcano expanded to steam, and it created this gigantic steam explosion, equivalent to 20,000 tons of TNT blast energy. That was directed not up, but northward over the landscape. And then we had the debris avalanche going into Spirit Lake, and the avalanche displaced the water of the lake up to 860 feet, creating this enormous or giant water wave on the lake. And then following that were mud flows. The heat of the explosion melted the snow and the ice around the volcano, and we had mud flows on 6 major rivers downstream. And then we had pyroclastic flows, especially on the afternoon of May 18th. The volcano erupted episodically, these frothed up liquid flows that came out. And then the rest of the day, there was airfall debris, and we call that the pumice that fell out of the atmosphere. We call that airfall tephra. So that's the kind of the story of the 9-hour eruption on May 18th in
There was
summary.
a lot going on that day.
Yes.
Steve, when we were walking up here, you were telling me that before 1980, if we looked down there, we would see a lush forest, but it's a whole lot lower than what we see. This has all been filled in. What happened? How did all the material get here, and what do we learn from it?
Well, we have a lot of deposits, don't we? There's up to 600 feet of deposits here in this valley. It was sky before the eruption, and now look what's going on down there. Okay, that is an amazing thing, just thinking about that. So a lot of deposition, up to 600 feet of deposits. And then the way the erosion has occurred in this area, it allows the layers to be exposed. And so we can see the sequence of events that formed not just this ridge, but the valley. Some of these events occurred as much as 2 or 3 years after the 1980 eruption. And so every event left a fingerprint of something here on the landscape. So we have Earth's newest landscape, and we have all the knowledge from eyewitnesses and from photographs to put together the sequence of events here at the volcano.
So we have mud flows, we have pyroclastic flows, we have these explosion pits, we have erosion, and we look out here and we see there's a lot of character to this land.
Yes.
But it all occurred rapidly through these catastrophic events.
Yes.
What does that tell a geologist who now moves their vision from what happened here at Mount St. Helens and then begins to look around the world at the geological formations that we have around the world.
That's my story, is I came here and I'm looking around elsewhere and I see the application of erosion and deposition and those kind of processes that are here at the volcano to many other features of the Earth's surface. I have studied strata, and rapid strata formation here indicates rapid strata formation elsewhere. And rapid erosion features here are like erosion features that we thought require millions of years. And we thought that layers form slowly and gradually, but here at the volcano, they form rapidly.
What's the primary difference between your observations as you see here and the standard geological story, and what is that?
The standard geologic story is the present is the key to the past. We look at the present day process of slow and gradual, and then we think into that. That applies to geologic features of the Earth generally. But it really isn't the story. It's not the present is the key to the past, it's the catastrophic event is the key to the past. And so Mount St. Helens is a window to help us understand the catastrophic formations elsewhere on the Earth. So the present is not the key to the past, the catastrophic event that we're seeing is the key to the past.
Well, Steve, thanks for making me hike down here. This is an awesome place. Where are we?
We're on the North Fork of the Toutle River, upstream near the crater of Mount St. Helens, and we're in this area that's been profoundly impacted by the deposition and erosion associated with the volcanic eruption of 1980.
So are you saying that the ground we're standing on was not here 40 years ago?
Yeah, this was sky before the eruption in 1980. And so up to 600 feet of deposits have formed here. We just see the upper 100 feet of layers here. But
but it's now been carved out for us so that we can look at it. You know, we can see some of those layers. And what do we see? What are we looking at?
Well, we're looking at mostly the bottom of the cliff over here. We're looking at the airfall deposit from May 18, 1980.
Is that the lower level that we see?
Yeah, the lower level. It's kind of a massive and fragmental deposit. That's what was falling out of the atmosphere from the volcano late in the afternoon of May 18. Right around 4 o'clock in the afternoon is when the eruption subsided, and so that top of that layer there, about halfway up the cliff, is the last airfall debris from May 18, 1980. And then this area was impacted by buried ice. Underneath us was large glacial ice buried in the debris avalanche, and then what happens is steam is reaming a hole to the surface, and we're seeing a steam explosion occur in the coarse debris right about halfway up the cliff.
How long did that happen after May 18th?
The first week or so.
First week?
In the first week or so, there was a big pit here. It was 100 feet deep and reamed out by steam. It was 2,000 feet long, 1,000 feet wide, and this gigantic pit was here. And then into that pit came the next deposits. On June 12th, 1980, about 9 p.m. to midnight, there was a big eruption of Mount St. Helens, another big eruption. And during that 3-hour period, there were enormous pyroclastic flows, high density, very hot slurries of volcanic ash that came out of the crater. This low area in the pit collected those volcanic ash layers. And so we see behind us, about halfway up the cliff to about 3/4 of the way up the cliff, we see a 25-foot thickness of layered volcanic ash. That's the pyroclastic flow deposit from June 12, 1980. And it formed just in the 3 hours there late in the evening. And then this pit sat here with the landslide debris and the other kinds of material, the volcanic ash all around it. And then mud flow of March 19th, 1982, that came down here at 90 miles an hour. It filled in this low area, the pit, with mud. And you're seeing the residue of the mud, about 25 feet in thickness there at the top of the cliff. As the mud came into this pit, it actually filled the pit with 100-foot thickness of mud. The pit was filled, and then what happened is the mud overtopped the debris dam that was downstream of here, and then it cut a spillway over the top of that dam, which cut back through here and gouged out the bottom of this pit and released the mud downstream. And so the canyon formed in a day on March 19th, 1982, by the drainage of the mud in this big pit through the debris avalanche.
So you sit here and you look at the complexity of the geological formations, and it would be easy for someone, if we just blindfolded them, brought them down here and took the blindfold off, to look around and think, as a lot of people do, man, this is really, really old. Look at all these different layers and all of this stuff that's going on, and yet each of these layers is laid down rapidly within a day and breached within a day.
Yeah, so
That's amazing.
So although it's spread out over 2 years, period, each of those individual events happens in just minutes or hours.
So we end up having a very complex geological formation here that was all done rapidly.
Yeah. You know, when I see thin layers, I think of slow and gradual sedimentation, one sand grain at a time, and that was my normal way of thinking. But here at the volcano, I learned that grains can segregate rapidly in layers by hurricanes, essentially. Those pyroclastic flows make thin layers in just seconds. And mud flows can move very fast, 90 miles an hour, and bring big boulders and lots of debris. And of course, they're very erosive. And so we see the power of these agents and the speed of these agents. And fortunately, because Mount St. Helens, I can understand those processes, and I can go elsewhere and see if I see the same thing.
Right. So you go around the world and you see those complex geological formations, and it's easy to see how rapidly they could have formed as well. Is that right?
Rapid stratification, rapid erosion. That's the story at Mount St. Helens, and it's the story around the world. I think there's plenty of application here to other geologic features of the Earth, and it's a wonderful laboratory for studying catastrophic process.
Steve, this is kind of an interesting place. What do we see here, and where'd it come from?
We're on the North Fork of the Toutle River, and we're looking upstream toward Mount St. Helens, and we see this major alluvial or mudflow deposit in this valley. This mudflow deposit ripped loose logs and all kinds of material that was in the valley, cut it down, and then filled it back up with mud.
So where did it come from originally?
The mud is up from the blast zone, essentially. And there's 150 square miles of blown down trees up there. And the ash and the sediment debris that's ripped loose, there was a major source of sediment. Not just volcanic ash, but also the landscape itself is very erosive and erodible. And here we are, tens of miles away from the base of the volcano. Some people thought they were safe in the valley this far away from the volcano. Their home was buried in mud. And
so there's a lot of destruction from this mud flow down even this far.
Yeah. On 6 major rivers downstream, on the North Fork of the Toutle River here, and 5 other major rivers, there was significant mud flow damage. Logging camps were overcome. Homes were buried. There were bridges washed away. There was more dollar damage from the mud flows than from the steam blast itself. And so you can imagine the threat that mud, how it's able to radically alter a landscape.
Well, other than giving us a more healthy fear for mud, what has a geologist learned? What have you learned from this? And especially, what does that then tell you about the rest of the world?
Yeah, we've learned how effective and how mobile and how easily transported mud is by studying the mud flows at Mount St. Helens and other things. So we did not appreciate the way that mud is able to move things. And it's like ketchup. It has a shear thinning rheology, and that mud is, once it gets moving, is very low friction. And it has in itself, the way it works, the ability to overcome barriers and by its momentum just erode things. And so this energy that has come back to our discussions of mud has proven very beneficial for the understanding of limestone layers. I can see the effect in limestones, how fossils are buried, sandstones with graded beds, and these coarse clastic layers called conglomerates with large pebbles floating in mud matrix. All of this has tremendous implications from the mud flow angle of looking at it.
So when I drive around and I see a lot of these sedimentary layers, I ought to be thinking more about how it used to be mud than the way I used to think of it.
Yeah, now geologists used to think about dilute flow. You know, the bottom of a creek is a dilute flow. It might be 5% sediment during a big flood going by. Okay, well, that type of flow, the sweeping action of the bottom of a creek, is not the major mode of sediment movement in the past, at least judging from the frequency of mud flows. Now, a mud flow is 50% sediment, 50% water. It's not a dilute mass, and so it has huge energy in just its momentum.
So we have a mud flow with a lot of sediment and material in it. How do we get from that to then the layers?
Yeah, well, mud can simply freeze by friction and de-water, and it's only 50% water, it's 50% sediment, so it's easy or somewhat easy for a mud flow to lose its momentum and just become very, very rapidly a sediment layer. And that shows up in the fossil record as some of these massive beds. But mud can also go through a process where it deposits sediment and then becomes a dilute fluid flow. What happens is, and that's what's observed here at Mount St. Helens, is the mud flow goes along, loses sediment at a low place like here, and then the sediment to water ratio, the water increases, and so we have dilute fluid flows that are very erosive, and that creates the familiar sandy layering that we know about in creek beds and other places. And that process is called flow transformation. A mud flow can resurrect itself into a tractive current, a sweeping action current. And when that happens, boy, you can make all kinds of sedimentary strata. So the understanding of that has really revolutionized geologists' understanding of how strata form.
When a mud flow itself, when it's still saturated with a lot of that material, can it be erosive itself?
Oh, very erosive. And that's what was observed here. Okay, the mud flows came by and they picked up bridges and just floated bridges down. Logs, everything, it floats, okay? And so an automobile floats on a mud flow. They freight things along, okay? And, we chuckle at thinking about how mud moves things, and I'm sure the people involved in the disaster of the moving mud don't like what they're seeing, but it is obvious that we need to think this way about the process.
Can a mud flow also cut down rather than just, go through bridges or collect bridges and so forth? Can it also cut down in below?
Yes, and now mud is seen to do that on the slopes of Mount St. Helens. The two canyons on the north slope of the volcano are very deep. Step Canyon is over 600 feet deep, eroded through solid rock, made by moving mud after the summer of 1980. And there's another canyon called Lewitt Canyon where it's over 100 feet deep, eroded through solid rock. 500-year-old lava flow. It didn't take tens of thousands of years to do that. It was basically mud moving down that channel very rapidly, plucking away and grabbing solid rock and excavating a canyon. There are people that say that today on the ocean floor, the main way that sediment moves in the ocean is by mud flows. They're concealed down there. And they think that mud flows can go 1,000 kilometers under the ocean, over the flat floor of the ocean. And so it may be even today mud flows on a more regular basis than we think here at Mount St. Helens are making significant sedimentary deposits. So our world is more mud flow than ever.
That's really interesting. Thank you.
Mistakes that they're making, and they're one of the major mistakes. Kind. They're taking what normally happens. You know, not. I mean, they learned a lot about St. Helens thing. They changed their whole idea as to what, you know, what actually happened. Just by the way of how it happens. You know, that, you know, he was saying that he changed his whole philosophy of what took place in places like the Grand Canyon. It answered a lot more questions on how quickly it can form and how quickly it can be eroded away. You know, nobody believes nowadays, especially in light of Mount St. Helens and other quickly eroded stuff. Nobody thinks today, a geologist in today's world kind of jettisons the idea of what we were being taught, still being taught in schools, about the Colorado River going down and making the Grand Canyon. You know, I mean, it just can't happen that way, because it's just going through granite, and granite doesn't, you know, just. So he's, you know, like he says there, he says, you can't take what happens today and just put it through to the past. The Ice Age guy, can't think of his name right now, but anyway, he said the same thing. You can't look at, you know, what's happening today with all of the ups and downs. He said it's from his view, it's a very stable. I mean, we can see it here in the weather that we have. You know, I've been alive now more years than I want to acknowledge, but you know, for 61 years, in the 70s, they said a new ice age is coming. Then all of a sudden in the 80s, it was like, oh my gosh, we're burning up. The world's coming to an end. And then it cools down again, comes back up, cools down again. It's going to take something extremely, like when the flood happened. What happened? Many different things. You know, the magma comes up, superheats the water, which creates the cool down of the earth because volcanoes are covering the sun rays coming in. I can remember I think it was a cold summer that year of Mount St. Helens, because it covered, you know, the dust and everything like that got up there and stopped the sun. So it was a much cooler summer than it was before. And of course that was, you know, life's gonna stop at that end. But what's gonna stop life next time, Tom? What's coming next time? It's not gonna be by water. It's gonna be fire.
I think they're really worried about Yellowstone, and they said that Mount Helens is like a small peak compared to.
Well, you look,
volcano
yeah.
erupted there.
Oh, yeah, yeah,
Would take out
if that
the
goes,
United
it's a major problem.
Yeah.
But look at all of the earthquakes that are happening out in the San Francisco Bay Area and up that area. I mean, they're saying that there's a huge volcano underwater
Right.
that may erupt too. But there seems to be a lot of earthquakes happening and stuff now, but you know, again, it's not happening all at once, like what what it says in the Bible happened with the flood.
I can understand watching this today, what happened to the city of Pompeii. You know, those people were
There's not much
so
warning, is there?
fast, they were sleeping in their beds when they didn't move. That's how fast it was.
Yeah, and and like you said, like they said, you know, it's not a slow that's why one of the things with this climate change, I don't believe it because it moves up and down. One year's cold, 1 year's warm, you know, and I just don't see it.
Well, even this month here, the month of May, the furnace has been on every day.
Yeah.
And we're supposed to be, you know.
Well, you're supposed to turn you're supposed to turn the furnace off because you're just, you know, making it colder anyway. So, I mean, it's just some of the things that they're trying to do and trying to just, I think they're making too many decisions based on what they see today. Thinking that it's going to make I mean, take a look at how long the earth has been here
Mhm.
and who's in control of it. I know they don't believe that, but who's in control of it? He's not gonna let it get out of hand unless he's directing it. So,
You know, like you say, you know, 70 years, over 70 years. I've seen, you know, the change in climates and stuff like that. But really, if you look at it, all these years, you know, I don't really see that much difference.
we call it what? Not climate
Weather.
change, we call it weather.
Yeah.
What's the weather gonna be like today? It's not like, oh my gosh, what's gonna be devastating about the climate
Well,
change now?
if you watch the news, they'll show the record lows and highs. And they can be extreme.
Mhm.
But within 100 years, probably past.
Mhm.
I don't know.
Now,
Before that, people weren't keeping accurate records.
Yeah.
right,
This is fluctuation that's routine.
and like the fella said today, he said, I find it coming from a biblical view that the weather is very stable. Because yes, it does change. I mean, what wouldn't change because there's things going on, but not to the extreme of what happened to start the flood. And you know, what happens with some of the volcanoes and stuff. Yeah, you know, we just called it weather. Some days, some years it's great snowmobiling. Some years it wasn't. And
Yeah.
when there was a lot of snow, couldn't snowmobile anyway because it's too deep.
Yeah.
I remember that vividly. So,
Even population movement can affect the weather.
mhm. Yeah. Yep. Well, even, I remember all the hurricanes that came up in Tennessee and, you know, South and North Carolina and stuff like that. I remember seeing the huge amount of water going down through there, and it was mud flow because there's trees, there are vehicles, there are bridges being taken out, everything, just like he was saying there at Mount St. Helens. Well, that was just a hurricane with a ton of, you know, well, I think more than one came up through there. And it just devastated the area down there because mud.
Yeah, they're having tornadoes now in the spring season. Tornadoes in fall season.
Mhm.
Yeah, there's a chimney line.
Yeah, so, you know,
Oh, no.
it's weather.
We're all doomed.
Yeah. I'll take an occasional blizzard now and then.
Mhm.
I don't want, you know,
You can always put on another coat. Or it can take so much off.
you can also use your snow blower and get out there and get it out, but, yeah, I mean, they even have changed the rainfall now. They call it lake effect. There is such a thing as lake effect rain.
Mhm.
You get more than usual, so. Well, I hope the series has been really good. I learned a lot. I still go back and look at this stuff
Yeah.
a lot, but you understood a lot more what he was talking about this time than at the very beginning. That's the reason why I thought it would be good to show again. So, this here, I can't get this to work, so I'm gonna hand it over to Mr. Reed so that he can get it to work, and cause this really kind of ties up everything and gives more information about after the flood and what happened. So, stay tuned for that. We may be able to break it up into two, cause it's over an hour long. So, but it's really good information. I think it will really tie up what we talked about here, so stay tuned for that. It might be a few extra ones. I'm very confident in Jim's ability to make this work. So, any other questions? Any more comments? Before we let you go, a few minutes early?
Yeah, I noticed too that these scientists now are finding out all this new information. But if you look at the evolution theory, there hasn't been any change in 100 years.
Why?
You know, that they're sticking to the same old stuff with no scientific proof.
So why would they do that?
Because they wanted us to believe there is no God.
Well, yes, and that's their religion. That's the base. That's why they have to have it, because the other option is there is a God. And oh my goodness, we have to be beholden to him. They don't want to do that. Yes, no.
In Great Britain, they have created this blanket to block the sun rays, and I don't know if anybody's ever been to England, I think it's one of the cloudiest
Well, there,
place, and I'm thinking, why would you trying to block the little sun that you're getting, you know?
well, you just have to take more vitamin D. You need, that's the vitamin D, that's the vitamin D pharmaceutical company wants you to buy more vitamin D. They're feeding the clouds is what they're doing. It's all over them. So they're trying to control the weather. How do you think that's gonna go?
Read Revelation, we'll know.
Yes, exactly. It's all gonna come to a crash and halt. But they have to. Cause that's their religion. That's what their belief is in. And they're just as adamant, as we should be on the other side. So. Cause the Bible can't be right. Or else I'll say that it can be, that it is. So. Good direction. Okay, Tom. Can you, pray us out today?
Let's pray together. Father, what a comfort it is to know you're in control of things. And that where we live is bigger than we realize, more detailed than we'll ever be able to comprehend. We know that you, Lord, have a plan and a purpose for this planet and our dwelling on it. And we desire, Lord, that each one of us render your control of our lives in such a way that while we're here, we'll be doing the desires of your heart and look forward to what you have us when you present before us a new heavens and a new earth. We're grateful, thankful for this day, and turn it completely into your hands with comfort in Jesus' name.
Yeah, that new heaven and new earth will be, the weather will be perfect, right? Just like it was in the garden.